Hey everyone, and welcome to the Advanced Airflow Lab tutorial. I hope you guys are doing well. In this tutorial, we are going to cover a variety of topics, including creating custom airflow operators to interact with custom and external services, optimizing tag performance, setting up advanced monitoring using cloud logging, Google Cloud Storage, and setting up alerts. We'll also talk about how you can integrate Google Cloud Composer with other services like cloud storage, like BigQuery, Vertex AI, and we're also going to be talking about some security best practices for your Composer environments, including IAM policies and network security. By the end of this, you will have an understanding of all these concepts and how to orchestrate complex processing tasks and workflows. So let's get started with the first part, and the first part is IAM and admin. So IAM, or the full form of it, as it stands for Identity and Access Management, is a framework that is used in Google Cloud and is also used in other cloud providers like AWS, Amazon Web Services, and it is used to manage resources. IAM allows you to control who has what access to which resources. For each of the user, you can give a particular set of accesses that they can use. Like for example, if I wanna give somebody only an access to read data from Google Cloud Storage, we'll give that kind of a role, Google Cloud Viewer access. If I want somebody only to create something in Google Cloud, create a bucket or create a bucket for example, then I'll give a Google Cloud create access. So let's head on to our IAM. So we'll go to IAM and admin from here. We're gonna click on service accounts here. So a best practice here is that for your Google Cloud environment, we should be creating a new service account. The by default, Google Cloud will provide you with a service account for your Google Cloud Composer, but we're going to make a new one. So we'll click on service accounts, and then we would create a new service account. So you will provide your service account name. For example, I have added Cloud Composer service account as the name, service account ID. It will it will create this based on the name that you provide here, right? And then you can provide some description that this is the service account related to my Cloud Composer. Then create and continue. I'll show you my service account that I have created. So my service account has these many roles. It has a storage object viewer, storage object creator, editor, composer, worker, Cloud Composer V2 API, and AI platform admin. So we'll talk a little bit about each of these roles that we have used here. Coming first with AI platform admin. This enables the service account to manage your machine learning models and jobs. The Cloud Composer V2 API Service Agent extension is a crucial role. So without this, your um, environment creation would fail and you would see some error like this permission is missing. The Cloud Composer V2 API Service Agent permission is missing. So this is important for the composer to manage and orchestrate your workflows. Composer workflow, Composer worker is necessary for running the task and workflows within Cloud Composer. Editor is a comprehensive role. It allows modifying most resources and is useful during the setup phase of the environment. The storage object and creator, as we talked about in the beginning, these are essential for accessing and manipulating data storage in the Google Cloud Storage. Right. After this, we would go to our environment in Composer. As you can see, I have already created an environment here, but if you want to create your environment, you can click on Create Composer to give some name here, and you are going to use the latest image here. And the service account that we're going to choose here would be the Cloud Composer role that we have created. This is the service account that we are going to use, and small is fine, standard resilience is fine, and then we'll click on create here. Now we already created the composer environment and we're going to be using that. Right. So that is about the first part. Second part, we are going to talk about how we can store logs in Google Cloud Storage, and we'll also talk about how you can set up an alert. An alert, there are multiple types of alerts that you could create in Google Cloud Composer. We'll talk about one basic alert that I have created. You just need to go to view alerting policies here, and the alert that I have created is log size alert policy. Let's see what this does. This is my limit. The red line is the threshold. So if the log size that I have increases, it will trigger an email. I just now received an email about that. Let me show you. So the alert here, as you can see, view incident resolved and alerts, all of these are a result of um, the threshold being breached. How do you, so this policy is enabled, I would disable it now, otherwise this would keep on sending me emails. But I could also adjust the frequency, the threshold to something higher than this. All right. So how do I create an alert? Just go for create policy, then select a metric. Now we would choose Cloud Composer environment here, right? Since we want alerts for that. Go to environment, and you have all these particular metrics that you could use. API latency, API request, salary workers, DAG bag size. So this would be about the total number of DAGs that you have in your DAG bag. If it increases a certain threshold that you set, it would um, it would throw an it would send you an email. You could configure it that way. So let's try the database CPU utilization here. Right now, okay, I would go to next. This is the threshold value. This is my current utilization. It's 0.08. It's less. So if it is about 10%, then trigger an email. We'll say make a alert like that. Now it will say notification channels. I've created one notification channel here, that is by email, but when you open this for the first time, you will not have anything here. Just need to go to manage notification channels, and then you can do an add new here. If you want Google Cloud to send you an alert on Slack, just say add new here, and then put your Slack credentials. You can also sync it with PagerDuty. PagerDuty is an app that you enroll the people in your organization here in the PagerDuty app. Everybody has that app, and then as soon as this alert reaches a certain threshold, let's say the CPU utilization is 90%, you don't want it to go 90%, right? So it will trigger a page to somebody who is on call that time, and that person has to check this and resolve the matter. So I'm going to use the email notification channel. Okay, and then notify on incident closure. So there are some incidents like the 10% CPU or the log one that I might not want to keep it open. I have a time limit that it should be resolved within 30 minutes, and then it should automatically get resolved. So I can put that duration here, 30 minutes, 1 hour, or I can put a custom time here as well. This is the severity level. If it's a normal, it's like a warning. This is the CPU for 10%. See, if the CPU usage has reached 10%, then trigger an email. So this is not that severe. So I am going to put it as a warning. Let's say it was something like CPU utilization is at 95%. Then I should keep it as critical, the security level, right? And you can add a text. This is the field to um, add any description or documentation that you would like that would be included with the notification, and this you would set up the name of the alert policy. Let's name it something like usage policy. Say next, and then I would just create the policy, right? So I can see this one here as well. I would disable it for now, right? So let's go back to our composer environment. Now we wanna think about so let me give you an example that sometimes what happens is airflow might be down, the environment might be down, but you want to debug the issue that why is it down or what happened, but you cannot go to the UI because it's not working. So in that case, something like you are exporting your logs periodically to Google Cloud Storage, that might help. Now how do we set up that? How do we sync our logs that that are sent here to our cloud storage? You would go to environment configuration. We would go to logging, this part, view logs. These are all my logs that are currently being published in the environment. Now we'll go to more actions, create a sync. We'll name the sync, say cloud storage airflow logs. Description, okay, cannot name it like that, right? Name, give some description for it, that what this logs sync the airflow logs to cloud storage. Next, sync service, we are going to select our cloud storage bucket here. Let's browse it. This is the bucket that I have chosen. I'll select it. You can choose particular logs that you want to choose to be included in the sync. For now I'll select the default ones and choose logs that you want to filter out. So it's an exclusion rule, and then you click on create sync. As soon as you do a create sync here, it will start syncing the logs to Google Cloud Storage, and it will not happen instantly. So if you directly go and see after you do this step, you will not be able to see the logs there. But it will sync in every 1 hour. So let me show you how it looks like. Cloud Composer logs, airflow monitoring. These are all the path, all the logs that I have. We'll go to airflow monitoring 2024, and we'll go to the latest today's logs. So this is by 2024. This is the month. This is the date. These are the logs from today. Let's see what they look like. Your standard logs for the environment, right? So that is the part about how you could use Google Cloud Storage to sync your logs. Now we'll talk about integrating different services like BigQuery, Vertex AI, and Google Cloud Composer in your Airflow DAGs. So let me talk a little bit about these services and then we will jump into the code for them. Okay. So this is my environment, yeah. So let's start talking about Google Cloud Storage. So Cloud Storage is GCS offers a scalable and durable storage for various types of data. You could put your images, you could put videos, and because of that, it's an ideal spot. It's an ideal service for archiving your data for backups and for content distribution. Also, GCS integrates seamlessly with other GCP services. So whenever you want to, in our example, we are going to load the dataset into GCS, and then we are going to read it in the Cloud Composer, and then perform some data validation on it. So it is used in such scenarios. BigQuery. BigQuery is a fully managed serverless data warehouse that allows for fast SQL queries using the processing power of Google's infrastructure. It supports large data analysis over a lot of data, over petabytes of data, enabling efficient data exploration and business intelligence tasks. Vertex AI. Vertex AI unifies necessary tools and APIs to streamline the process of building, training, deploying your machine learning models. It provides services and infrastructure that allows data scientists and ML engineers to focus more on developing the models without worrying about the infrastructure behind them. Now let's dive into the code. This is our DAG. This is the DAG to process data and perform some analysis in BigQuery. So first task is to download and serialize the data from GCS. Then we are going to clean data, upload the cleaned task, like upload the clean data back to GCS. And then we have a file sensor here that senses that the cleaned file has been uploaded to GCS. So the reason we do that is that, let's say there's some error in the functioning in the upload clean task. This, let's say this failed. Then we want to make sure that we get a trigger that the um, the task has succeeded or it has failed, and we use sensor in this the GCS object sensor in that case. After this, we want to only after the file has been uploaded, we want to make sure that we load the data to BigQuery, and then we perform some analysis on it. And then I will just send an email to my email saying that it saying that I have it's a sample email about my task completion. And after that, we are going to trigger another tag using this task. This is the flow. This is the graph for it. The order of the execution. Right now, let's check out the code. What happens here? Download and serialize data. This is we passing the bucket name here. Bucket name and the object name, and then we are using GCS hook to download the file. Now after downloading the file, we are going to make it into a JSON, and then this will call the second task. which is clean the data. So this clean data task, it basically uh, fills the missing values. It normalizes the values. We're using 95th percentile as the cap here and then we are normalizing the temperature readings, and then we are going to use that file path and call the other task which will upload it to a GCS location. This is the upload clean task, upload clean data. We are using xcom pull here, so we are basically passing the data between the tasks, and for that we use xcom pull. Now this, let's see, so you see have the task id here. This is the task id for clean data. You have this argument here, and after that we are going to upload it on the location that we have mentioned here. Now we're going to perform some BigQuery analysis on it. This is the query that I'm using here, and then I'm going to log the result. We'll see all of the output when we run our code, and then we are using send email. So the thing that is important here is that we're going to be using variables here. This is hard coded, but you can use this also as a variable, but that is how it is right now. And we this is the subject, from, and to, and we are using the Python's inbuilt SMTP library for sending the email. Some of you might be facing some problems while sending an email here. So you need to remember that if you're using a Google email to send out the emails, you need to make all the configurations, like set up your SMTP server. You should have your SMTP URL, and you should have created an application password as well. Let's check out the variables here and then understand a bit more about it. Yeah, so these are my DAGs. We go to admins and we go to variables. Now whenever you want to add a variable, for example, as I have here, variable.get email user, variable.get email password. This is the user email and password that I have created to send out the email. You can do it, just click on actions here, add a new record, not actions, just on the plus sign to add a new variable. Say this password. This is the key value pair. You have to paste your actual email password here that you generated. Basically, you need to generate an app password for this to work. Now let's trigger our DAGs and see. This is the first DAG. As soon as this completes, it should trigger the second DAG as well. So we're just going to trigger the first one. Let's open this up. This is the graph for our operations. As you can see, it's everything happens one after the other, because in this there no two tasks can run parallelly. Everything happens one after the other in one sequence. But in cases where you have 3 or 4 tasks, let's say that they do data processing but they are not related to each other, you can always run them in parallel to optimize the performance of your airflow pipeline. So it will not be linear. It will not wait for the first one to complete till the second one will not wait for the first to start. So you can use parallelization in that case. So we can see that load to BigQuery, this it is successful till here. Send email is also successful. I received an email. This is a sample test email from Python, and trigger the second tag. This is queued. Let's see the logs for this. Task exited with 0. Means the second tag has also been triggered. Let's see the BigQuery analysis. The output of the BigQuery analysis is this. The SQL query that we had used resulted in this output. Check out the BigQuery so that we can visualize how it looks like. This is my data that we loaded. These are the columns: date, household 1, 2, 3, temperature and humidity. Let's see the data. Yeah, this is the preview of the data that we have in our BigQuery. That's the date, the humidity, temperature, everything. So basically this is a time series data set that is used to predict uh, how much the household 1 is going to use the energy consumption of household 1 based on factors like temperature and humidity. This is about our BigQuery analysis. Go back to the tags. Now it was 4 here, it is 5 right now. Let's see what this does. These are our 2 tasks that have been successful. Now let's talk a little bit about custom operators and when we should be using custom operators. This diag that we have on the screen right now uses custom operators. So going back to the code, custom operators are in the plugins/custom operators folder, and then in that you have ML operators. Now I've created 2 operators here. One is an ML deploy operator and the other is ML model train operator. As the name suggests, the ML model train operator is used to train machine learning models. We are going to be using pandas and scikit-learn for that. This is the machine learning code that trains the model. And then after training the model, we are going to load it into Google Cloud Storage, and then we are going to use another operator, that is the ML deploy operator, and we are going to use it to deploy that stored model from GCS on Vertex AI. So how we do that is we call the Vertex AI's APIs, right? We will talk about it uh, in a minute, but before that, let's see what are custom operators. So basically, custom operators in Airflow, they provide a way to encapsulate complex logic and make your workflows more modular, and it also makes the workflows easier to manage. So here some reasons that why we should be using custom operators are that first is encapsulation of complex logic. Custom operators allows you to encapsulate complex multi-step processes into a single reusable unit. My model deploy operator here and my model train operator, they are single modular and reusable units, right? This makes your DAG cleaner and easier to understand, right? The other thing is reusability, as we talked about, and maintainability. It is very easy to maintain this kind of a custom operator, and yeah, so when somebody else is looking at the code after you, they can easily make changes to this, and it's more readable. So you use custom operators when you cannot find an inbuilt operator that does the job for that you want. Now let's see how these are used in the code. Right. So this is the second tag that gets triggered. This is the ML model train operator. It's task ID. This is the data path. This is the path for the clean energy consumption file that we cleaned in the first DAG. And this is the bucket name. This is the models folder. And then after training it, we would deploy the model. Okay. Now to deploy the model to Vertex AI, we need the Vertex AI admin IAM permission that we talked about in the beginning of the video. And also, let's go to Vertex AI. We're here. Recent models. These are our models. This one is the one that we deployed just now. Let's go check this out. When we go to deploy and test here, we can deploy our model to an endpoint, and then we can use that endpoint to make predictions from using this model. We go to deploy to endpoint. We're gonna name something. This is the region, and continue. Machine type, you can just choose the lowest configuration here. Service account is not needed, and then continue. And we can enable monitoring. This is the part of continuous monitoring. If you want to enable it, you will have the model monitoring interval, the name, notification emails, where do you want to send the notification in case it reaches a certain threshold, and then but we are not going to be using it right now, and then we would just say deploy, and this would start deploying the model that we deployed this model to an endpoint which we could use later on. Okay, and another thing about using Vertex AI is that when you first reach this part, you have to click on enable all recommended APIs, and you would see something like 17 or 19 here. 19 is two more that I got some time back, but it would be something like 17 APIs that it would enable. These data form, dataplex, artifact registry, everything. All right. And you could also create another DAG using which you could make a prediction. This is a sample DAG for your model prediction that you could use. is your project ID, your endpoint ID, and the instances that you use for data prediction. Let me show you what an instance is. Go to our model that we just tried to deploy. This will take a little bit of time. This is the kind of an instance that it expects, the endpoint. And um, this is how you could get a model prediction. And this is about how you would create um, a pipeline and manage your workflows using Airflow and have your custom operators. And I hope that this was an insightful lesson. And yeah, if you have any comments, leave it in the if you have any suggestions or any doubts, leave it in the comments below. Thank you.